So this is question number 9.1 of ray optics. The question says a small candle 2.5 centimeter in size is placed 27 centimeter in front of a concave mirror of radius of curvature 36 centimeter. At what distance from the mirror should a screen be placed in order to obtain a sharp image? Describe the nature and size of the image. If the candle is moved closer to the mirror, how would the screen have to be moved? Okay, so it has three questions. Let's see how we can write the solution of this question. Before writing this, you have to visualize the ray diagram of this problem particularly. So we have a concave mirror here, over here, right? And they're given it is the radius of curvature of the mirror, and then the object is placed here, right? And the image is forming here. The distance you can see 54 centimeter for the image, 27 centimeter for the object, 36 centimeter in front of mirror radius of curvature, and 18 centimeter is the focus you are going to get with the formula of r by 2. Okay, so now before going to the solution, you have to see that how we solve this question, right? So as we have seen here that while solving this, first of all you have to write the given that is obviously in every questions. But next what you have to do is you have to write all this h u r with sign convention, right? With sign convention. And here a student do mistakes. If they don't know sign convention, they put the wrong value in the formula, and in the formula like in the mirror formula, and they get wrong values, and as the at the end they got wrong results, right? So this is very important that you know the sign convention. First of all, I let me clear the sign convention to you, then I will come to the answer of this question. So in the direction of the incident ray, the incident ray is this, right? So in the direction of this incident ray, we take positive. So this direction is positive. Always take the direction positive in the direction of incident ray, and obviously the opposite direction is going to be negative once you have done the positive direction, right? So now what you have to do is if you have to find the value of u, that is object distance. So what you have to do, it is given in the question that is 27 centimeter in front of the concave mirror, like in this way, in front of the concave mirror, right? So for this you have to go to the pole of that pole of the mirror, and you have to go 27 centimeter in front of the mirror. The front of the mirror is this, right? So you have went 27 centimeter this way, and now see that in which direction you have gone, that is in negative direction. So write negative direction, negative 27, right? Similarly for r, when you have to write the r, what you have to do is, it is given that the r is in front of concave mirror, so you have to 36 centimeter in front of concave mirror, right? So from the pole you have to go 36 centimeter, and then you have to see that in what direction you have went. So in minus negative direction you have gone, right? So that's why we have again take negative with 36 centimeter. So that how you have to take direction. Similarly, if v is given in the question, you have to do the same thing in front of the concave mirror. Then you have to see the direction in which direction you have went, that is negative. So put negative in front of that value, right? So this way you have to do things, and after that you have to proceed, otherwise you will get wrong result. So now we need in this formula, we need focus, then u and v you have to find out, right? So first of all you have to write u and r will give you the focus by r by 2 is equal to f, we know, right? So same way I have like obtained the value of u, that is minus 27, by fixing that direction sign convention, and then r, that is minus 36, not 36, minus 36, because it is in the front of the mirror, and in this direction the values are negative, right? In negative direction, negative 36, right? Now I can I have to first of all calculate the focal length, that is f is equal to r by 2. F is equal to minus 36, you have to put minus 36 in place of r, minus 36 that you have obtained here. So minus 36 by 2 is equal to minus 18, that is f is equal to minus 18 centimeter. Then finding position of the image, by using mirror formula. 1 by v plus 1 by u is equal to 1 by f, and that is you have to put the value u is equal to minus 27, not 27, minus 27, right? After that, for f you have to put minus 18, then you will get the value of, after solving, v is minus 54 centimeter, right? So this will tell you that the screen should be placed at 54 centimeter in front of the mirror to get the sharp image. So minus 47 is what? Minus 47 says that in minus direction from the pole, 54 centimeter in minus direction, from pole 54 centimeter in minus direction. So here is your image is forming, right? So that what you have to keep in mind, minus is in the minus direction 54 centimeter. So this way you can obtain that where you have to place the screen to get the sharp image, and then you have to find the magnification in the second part. So m is equal to height of the image by height of the object, that is also minus u by v, right? Minus u by v. So you can get from here minus u by v, and after solving this, after putting the value of v is minus 54 and u is minus 27, we are going to get minus 2 as a result of magnification. Here minus 2, the minus 2 can also be written as h naught by h, that is image height by object height, and from here you can obtain the image height from here, and that is minus 54 centimeter. And image height at object height is how the sign convention works here. So image height is above the principal axis. So above principal axis height is taken as positive, below principal axis height is taken as negative, right? So for image the height is plus 22.5, that is positive, but for object, sorry, but for image it is minus 5 centimeter. That means ki it is below the principal axis, minus 5 centimeter below the principal axis, minus 5 means, right? So you can see here that it is minus 5 centimeter. Minus 5 centimeter means 5 centimeter below the principal axis, right? And now nature of the image that is formed. So m is equal to minus 2 means minus sign denotes that it is real and inverted. And also if it going to become positive, that means it is virtual and erect. But here it is real and inverted because of this minus sign with magnification. Also you can say that if magnification is greater than 1, it is magnified, and if it is less than 1, if this value is less than 1, it is diminished, right? So you can also get that from here, and also from calculating the height, image height, that is 5 centimeter, minus 5 centimeter, sorry, and that means it is magnified. Image height is greater than the object height. Object height is 2.5 centimeter positive, but here it is 5 centimeter, that means it is magnified, right? And the third question is effect of moving the candle closer to the mirror, concave mirror it is. So if you move the candle closer to the concave mirror, the image will shift backward. Like if you are moving, let's we come to the ray diagram where you can get a clarity regarding this. So if you will going to move this, if you will going to move this image in the direction of this ray, or in front of that mirror, concave mirror, the image will shift backward, more backward. As you can see, it is happening. Like if this image is outside of the focus, your image is going to form here, but as you move here in the direction of the mirror, you will going to see that the image is going far away. So that happens in concave mirror. So that is going to happen. So the image will move away from the screen when the must be move away. So a screen must be move away. So when you move the candle in the direction of the mirror, the image will move away. That is the thing. Okay. So I hope it is clear to you, and always remember the sign convention to use before starting the question. Otherwise you are going to get wrong results. Okay.